Hi, it's TJ Chambers from smokescreendesign.com, and today we've got something interesting to discuss, something that's going to be intriguing, and uh, I want to get people's feedback and thoughts on it. We're going to talk about sea level. Now, it's always been my thought that, because I just never really paid much mind until I came across people discussing the flat Earth, that sea level was just kind of like this. We've got the waves and the water. And generally speaking, it's there's a median, there's a middle level between the high tide, low tide. I mean, we do have waves. Some waves tend to be bigger, in other places it's calm. But there's a median somewhere in there that there's a level measurement. And then anything above this median, middle measurement, that's anything above it's going to be above sea level. Anything below is going to be below sea level. And we've got land that does whatever it does and kind of pops up and whatever. So when we get down to the water, we go to, say, the ocean and the beach, depending on the tide. When we're at the water, we're going to be at sea level. We might be a little bit above, a little bit below, depending on what the tide is. And so in my head, the way I had it pictured out was for level, flat. Because I've worked in construction, level means flat. And so this is the way I've always had this in my mind. If it's not level, then it's not flat. So then someone brought to my attention that, well, if we have a globe, a sphere, water can't be level. You think about this. This water is curved. It's not level. And because it's a sphere, it curves 360 degrees from this point. So all the way around, the water curves. It's not level at all. So either they're playing games with us with the shape of the earth, or they're playing games with us on the word level. And there's only one shape that level, or yeah, I guess I'll call it a shape that level, sea level works. And minute physics, we're going to, one of the things we're going to do is watch a video from them. They're going to disprove NASA. They're going to disprove or debunk, whatever you want to call it, the education system. And then Neil Tyson DeGrasse, we're going to listen to him. He's also going to do the same thing. He's going to debunk NASA and our education system and what we've been taught about the Earth. So this brings me to a question. Is this what our Earth looks like? Is this the shape of Earth? Assuming that Google got this from NASA, got this idea of the Earth and everything from NASA. So what's the shape? Is this the shape? Is this the shape? Maybe this one's the shape. Now, if you put this in front of children, they're like, this is the shape right here. Maybe most adults, maybe 99% of people would say this is the shape. Now, we've had this image put in front of us for a very long time. NASA said that this is the photo of Earth. This is what Earth looks like. This is its shape. It's a perfect or almost perfect ball. Which, if you think about it in nature, is kind of an amazing feat to be able to do that. But the most recent picture of, I wanted to go back here, that NASA showed us, that this was taken 1 million miles away. 1 million miles away from Earth, this was taken. showing that the Earth is a perfect ball. Now, problems with this is that North America is kind of disappearing behind water, and it's really kind of a really bizarre shape. It seems that North America is pulling away from South America. South America, you can't even really see it. I don't know, it looks like a bunch of South America is missing. And we won't even worry about that. Somehow someone photoshopped sex right into the picture, but I guess that doesn't really mean anything. And then there are some, if you zoom in closer, then you'll be able to see that there are some different clouds that have been photoshopped in to where they've just taken these shapes like over here and just kind of clone them, just re-add them over and over again. But NASA would never lie to us. Never. Never. I mean, even though these have extreme differences, I mean, NASA would never lie. So let's take a look at what Neil has to say.
To the astrophysicist, we don't really care much about sea level.
No.
If you want to be high, you're measuring your distance from the center of the Earth.
From the very center of the Earth.
Is that different from the center?
I'm trying to give it...
the very center of the Earth. So you want to find the farthest point from that center. And it turns out sea level at the equator is farther away from the center of the Earth than sea level near the poles. It has nothing to do with global warming and melting of the ice cap.
So if you just heard what he said, that at the equator is further than at the poles. But not on a perfect sphere, it's not. I mean, on a perfect sphere, the radius is going to be the same all the way around. Let's keep trying to find out what he's talking about.
Why is that?
Because Earth, we know it spins once a day. Yes, thank you. 3 people know how long a day lasts here.
Good for row number 2. They're off to a great start.
So you spin, when you spin pizza dough, it kind of flattens out.
Yeah.
Gets wider.
So right now he is comparing Earth to pizza dough. That doesn't even sound like an equivalent explanation to me, because if you're saying that, number one, if you spin pizza dough, it flattens out. That means pizza dough is flat. It's flat. So then if you spin Earth, if it's like pizza dough, then Earth should be flat, is what he seems to be saying. But what he's saying is that it starts to stretch out. But just keep that in mind, what he's saying here. These are illusions, magical tricks, plays on words.
In the middle. So Earth, throughout its life, even when it formed, it was spinning. And it got a little wider at the equator than it does at the poles. So it's not actually...
So right now he's saying that Earth is wider at the equator than it is at the poles, but not from what Google Earth tells us, not from what NASA tells us. So right now either Tyson is a liar or NASA's a liar. So which one is it? We've got all these pictures of Earth that NASA provided to us, and other people replicated off of that. We also have the supposed, alleged pictures of Earth from the moon, which still show this perfect sphere. So which is it?
A sphere, it's oblate, and officially it's an oblate spheroid.
Okay, so now we are an oblate spheroid. Did I just spell it right? I did. I spelled it wrong. So oblate spheroid is like this kind of sort of flattened shape. So based on what he's saying, it should look more like this. So which is our Earth? Is our Earth like this? Or is it like this? Because that's a huge difference. That's a really big difference between the two. So right now, either NASA's lying or Neil is lying. Because you can't believe both are correct. Because it's in two different.
That's what we call it. But not only that, it's slightly wider below the equator than above the equator.
A little chubbier.
So now he's saying it is wider below the equator than above the equator. I'll go
Chubbier.
Yeah.
Chubby's a good way. It's like pear-shaped.
Yeah.
Okay, so now he's saying it's like pear-shaped. So this is a pear, and which this is a full pear, which he seems to be saying it's more. Oops, kind of didn't follow that very well. He's saying it's more like this, to where it's chubbier below the equator than above. Well, we've got a lot of problems with that. A lot of problems. Think about this. I mean, just doing a radius is going to, or a diameter is going to be so difficult to even try to figure out measurements based on this. This is because a lot of the calculations that are used right now to determine Earth's curve, and I mean that's a big one, is going to be Earth's curve, and using distance for measurements of objects in the sky, and this just changes everything. So not only is he not saying it's not a perfect spheroid, it's not a perfect sphere, it's this bottom half of the pear. And below the Earth equator, it's wider than above. So how is it that we don't see this? How don't we see this chubbier at the equator, thinner at the top? So either we need to start discounting what Neil is saying and believe what NASA is saying in regards to this, or we need to say Neil is telling the truth and NASA is lying, or we need to say you are both liars, both of you. You can't even make up your damn mind, you're both lying.
So, it turns out the pear-shapedness is bigger than the height of Mount Everest above sea level.
How?
All right, so the pear-shapedness is bigger at the equator than at Mount Everest. So what is this going to mean? This is what he's about to say. Ecuador is right here. There's this mountain here, which is Chimborazo or something like that. And what this means is that, and we're going to see this in a little bit, that Mount Everest, and this is going back to a play on words, the illusions, they try to change what we can see and experience and know. Mount Everest is 29,000 feet above sea level. Chimborazo is 20,000 feet above sea level. Based on its taller, wider, whatever at the equator, this is going to make this elevation way higher than Mount Everest. So essentially what he is saying is this, is that and now this, Mars, is a perfect sphere, not a spheroid that's imperfect. So what he's saying is that this here, there's this curve at the equator. This is taller than this and this. Even though if you have, this is 29,000 feet in elevation and this is 20,000 feet in elevation, because this curve is higher, this automatically becomes the highest point, not this, just because of that bulge. Even though this is 9,000 feet higher than that one. So this is the trick that they are playing on us, and we will just continue to listen.
How much higher is the tall mountain that you identify in this book, which name I forget, and probably you do too, in Peru, or is it Ecuador?
Ecuador.
Ecuador. How much higher, if you were on top of this mountain in Ecuador, how much higher than the Mount Everest would you be?
There's a 20,000 foot mountain in Ecuador, which is right. Ecuador is like near the equator, hence Ecuador.
Oh, you're just not giving up.
And that mountain is actually, the summit of that mountain is 1 1/3 miles higher away from Earth's center than the summit of Mount Everest.
1 1/3 miles higher. So what he is saying is that over here in Ecuador, it is one and do it like this. 1 1/3 miles higher than Mount Everest. 1 1/3 miles higher. I mean, that's pretty high. Just because of this supposed oblate spheroid is fat at the equator, now this is 1 1/3 mile higher. So what this also means that there is this giant hump right here that is 1 1/3 mile higher than other places. So you've got this hill right here that at the highest point is 1 1/3 mile higher. So that means these ships have to go over this giant hump. I don't know about you, but this just sounds ridiculous to me. Ridiculous. Now, we've got gravity. You'll never notice a difference. You will never ever even feel anything. The boat's not going to rapidly go down because this is going downhill, so to speak, because of the way the globe, the oblate spheroid, the way it sits. They're not going to go downhill at any greater speed or slower speed, or they're not going to go up. You're not going to feel a thing. Even though you're going up 1 1/3 mile high, you're there. You won't notice any difference. None at all whatsoever. Don't worry about it.
Okay. Question number 2.
But you got to know, let me just so you understand. We've been fed a lie our entire, I want to call it a lie.
He doesn't want to call a lie. We've been fed a lie. So right now, he is saying that NASA is feeding us bullshit. Now, by NASA putting out their images, they're saying that Neil is talking some bullshit. Who is telling the bullshit here? Now, this means that either NASA's lying to us or schools lying to us, globe makers, well, they just go off of the information that's out there. So the education system is lying to us based off of all the information coming out. So who are the ones that he wants to call liars that have been lying to us all of our life?
We've been fed.
It's a point of view thing, I think.
Earth has been misrepresented to us by geologists because the globes.
Oh man, it's geologists' fault. They've misrepresented Earth. Let's forget the fact that the globes are perfect spheres based on NASA. Let's forget that part. Let's just see what we've been so deceived about.
That you buy, that you rub your fingers over it, and you feel the Himalayas and you feel the Rocky Mountains. No. No, okay? These mountains are puny compared to the size of the Earth. You would not know they were there. If you were truly that size, some big cosmic giant lumbering through space, coming upon the Earth, rubbing your hand on it, the depth of your, what do you call these?
Your finger.
The fingerprint mark.
Mark.
The depth of that would be greater than the entire range of distance from the Marianas Trench in the bottom of the Pacific to the top of Mount Everest. Therefore, you would close your eyes, rub your finger, you would not know whether you are on ocean, valley, mountain, or hill.
Well, it might be wet or dry. It might be,
Well, by how much wet?
A little.
How? No.
Yeah.
You wouldn't even notice it.
Now that's complete horseshit about you wouldn't even notice it was wet because, I mean, there's a lot of water on the face of the ball Earth, and I've had my hands on balls that didn't hold a lot of water and my hand got soaked. But anyway, let's just...
You're not going to say, oh, I got to dry my hand? The depth of the ocean doesn't measure up to the depth of your fingerprint. That's my point.
Oh.
So we've been fed this misrepresentation of our own planet on the belief that, in fact, we have real surface features. But cosmically speaking, we're practically a perfect sphere.
Well, hold on a second. We mean practically speaking.
Fed this misrepresentation of our own planet on the belief that, in fact, we have real surface features. But cosmically speaking, we're practically a perfect sphere.
That's over my head. Cosmically speaking, we're a perfect sphere, but in reality, we are an oblate spheroid. Yeah, okay, or whatever. So we're going to take a look at this minute physics explanation about sea level. Sea level only works in one area with ease. Everything else, you're going to see how complicated this gets. And it's so mind-blowing, all the crap that they have to come up with just to explain this ball, when in reality they tell us how it works the best in only, well, let's see what they've got to say.
Sea level seems like a pretty easy concept, right? You just measure the average level of the oceans and that's that. But what about parts of the Earth where there aren't oceans? For example, when we say that Mount Everest is 8,850 meters above sea level, how do we know what sea level would be beneath Mount Everest, since there's no sea for hundreds of kilometers? If the Earth were flat, then things would be easy.
Oh, there we go. Let's just go with that. If the Earth was flat, it would be easy, and we can just... Let's just close this case and just like move on.
Just draw a straight line through the average height of the...
See, this is, as I explained before, this is exactly how I've always pictured sea level. Sea level is just anything above this level C, and I've never thought about it in regards to a flat Earth, but this makes the most sense to me, and this is how I've always pretty much pictured it, and it wasn't until I really started looking at the sphere Earth that it became complicated.
Oceans and be done with it. But the Earth...
Let's just hear this one more time.
would be easy. We'd just draw a straight line through the average height of the oceans and be done with it. But the Earth isn't flat.
Well, I'd say we could just be done with it and just Earth is flat and it works
If the Earth
easy.
were spherical, it would be easy too, because we could just measure the average distance from the center of the Earth to the surface of the ocean. But the Earth isn't spherical. It's spinning, so bits closer to the equator are thrown out by centrifugal effects and the poles get squashed in a bit. In fact, the Earth is so non-spherical that it's 42 kilometers farther across at the equator than from pole to pole. That means if you thought the Earth were a sphere and defined sea level by standing on the sea ice at the North Pole, then the surface of the ocean at the equator would be 21 kilometers above sea.
So just keep in mind with this that the radius and the diameter, that on a spheroid, things just don't quite work out like they did on a perfect sphere. So this changes all measurements, which I don't know of any easy formula that you can have to figure this out because of the changes. Now, Neil says it's not even a perfect oblique spheroid, that here in the equator it's bigger, and below the equator it's bigger than the top. So it's not even perfect, it's imperfect. So how can you even come up with measurements for something so imperfect? I mean, the only way I know of is to do real measurements, or to have some type of real camera out in space taking real pictures, which we already seen that, well, if it is an oblique spheroid, then NASA's lying to us and those are not real pictures. Or these guys are lying to us and NASA is giving us the real pictures, or they're all just lying and sea level is just easier on a flat Earth. It's just easy and then you can just be done with it.
Sea level. This bulging is also why the Chimborazo volcano in Ecuador, and not Mount Everest, is the peak that's actually farthest from the center of the
So this is a good picture of what Neil was talking about, that because of this bulge here that is up, remember it's 1 1/3 miles higher than everywhere else. So this volcano actually sits, this here is actually 1 1/3 miles higher than this here, which just sounds ridiculous, but perfect picture.
is also why the Chimborazo volcano in Ecuador, and not Mount Everest, is the peak that's actually farthest from the center of the Earth. So how do we know what sea level is? Well, water is held on Earth by gravity, so we could model the Earth as a flattened and stretched spinning sphere, and then calculate what height the oceans would settle to when pulled by gravity onto the surface of that ellipsoid. Except the interior of the Earth doesn't have the same density everywhere, which means gravity is slightly stronger or weaker at different points around the globe, and the oceans tend to puddle more near the dense spots. These aren't small changes either. The level of the sea can vary by up to 100 meters from a uniform ellipsoid, depending on the density of the Earth beneath it. And on top of that, literally, there are these pesky things called continents moving around on the Earth's surface. These dense lumps of rock bump out from the ellipsoid, and their mass gravitationally attracts oceans, while valleys in the ocean floor have less mass and the oceans flow away shallower. And this is the real conundrum, because the very presence of a mountain and continent on which it sits changes the level of the sea. The gravitational attraction of land pulls more water nearby, raising the sea around it. So to determine the height of a mountain above sea level, should we use the height the sea would be if the mountain weren't there at all, or the height the sea would be if the mountain weren't there but its gravity were? The people who worry about such things, called geodetic scientists or geodesists, decided that we should indeed define sea level using the strength of gravity, so they went about creating an incredibly detailed model of the Earth's gravitational field, called creatively the Earth Gravitational Model. It's incorporated into modern GPS receivers, so they won't tell you you're 100 meters below sea level when you're in fact sitting on the beach in Sri Lanka, which has weak gravity. And the model has allowed geodesists themselves to correctly predict the average level of the ocean to within a meter everywhere on Earth, which is why we also use it to define what sea level would be beneath mountains, if they weren't there, but their gravity were.
Well, I don't know about you, but that seemed extremely complicated for trying to determine sea level. So let's just go back and we'll just end it right here, because this is...
If the Earth were flat, then things would be easy. We'd just draw a straight line through the average height of the oceans and be done with it. But the Earth isn't flat.
that just makes way more sense to me. With all this, if the Earth was flat, it would just be easy, and that's how you would determine it, and you don't need all that other calculations and nonsense and perfect sphere, oblate spheroid, ellipsoid, whatever the hell it is. So go ahead, leave your comments, your feedback, and if you've got some of your own thoughts on this, I'd like to hear about that. And anyway, thanks for watching.